Afternoon, guys. I quickly want to explain to you guys longitudinal waves. Very straightforward. It works on the same principle as the transverse wave, except that it moves in a different way. So in the previous session, we looked at transverse waves, and we said that they move like this. A longitudinal wave moves parallel to the direction of propagation, which means that imagine you have a slinky in your hand and you push it forward and you push it backwards. That is how a longitudinal wave moves. So when we have a longitudinal wave, there are different sections in a longitudinal wave. So let's just say this is what it looks like. Then this part here, where the particles are closer together, these parts are called your compressions. And this part, the part where the particles are further apart, are called rarefaction. All right. Now, in order to determine a wavelength, you are going to go from the middle or the beginning of, let's go from the middle of a compression to the middle of the next compression. And that will give you one wavelength. So basically, if we have to draw a transverse wave to represent it, it's going to look something like this. So then you see, you have your full pulses, two full pulses. You can also measure a wavelength from the middle of a rarefaction to the middle of the next rarefaction. So then this will be your wavelength. And it's also important to remember that sound waves are longitudinal waves. All right, let's go to the calculations. In the previous section, we mentioned frequency and period. Okay, let's go and look at these calculations that I asked you guys to work out. So let's see. A wave has a frequency of 50 Hertz. Calculate the period of the wave. So which example? We are going to use this equation because we have to work, sorry guys, this equation because we have to work out period, and period is represented by T. So we're going to say T is 1 over F. So then you're going to write 1 over 50, and you're going to get your answer in Hertz. Okay? If we have to work out the frequency, you are going to use the first equation here. Frequency is 1 over period. There's your period. It's going to be 1 over time. And then you give me your answer in seconds. That's all you do. Now I want us to go to page 87 in your textbook, where we will use these examples to go and calculate some of the answers. Let's go to activity 1 on page 87. Let's do number 3 together. All right. Let me just get my textbook. Page 87. Number 3. A vibration has a period of 0.005 seconds. So there's your time. Calculate the frequency. Give the answer in Hertz. All right. So we have our time. So we're going to say frequency is 1 over time, 1 over 0.0005, and this gives us 2000 Hertz. To convert to kilohertz, you simply divide by 1000, and this will give you kilohertz. And that's it. Let's do number 4. A guitar string vibrates with a frequency of 250 Hertz. Okay, there's my frequency. What is the period of the vibration? So now we simply have to go and work out T. So we have T is 1 over F, 1 over 250, And this gives me 4 times 10 negative 3 seconds. Okay, let's do number 5 together. Number 5. A wave generated on a slinky has a frequency of 5 Hertz. 5 Hertz. And a wavelength of 0.75 meters. Guys, while we are on this, your wavelength must always be in meters and your time must always be in seconds. Because remember, my velocity, we are going to work with meters per second. So you cannot have kilometers or millimeters there, and you cannot have minutes or hours there. We have to work with meters and seconds. And then the question is, we have to calculate the speed. So now we go to this one. Speed is frequency times wavelength. My frequency is 5. My wavelength is 0.75. And this gives me 3.75 meters per second, negative 1. And those are your calculations. If you don't, for example, if you don't have frequency and they ask you to work out the velocity, then you can use the distance, so the length in meters over your time. If you have your wavelength, for example, so that will then be your wavelength. And then we will give you time, so we will give you one of these. All right, let's say, for example, let's work back. Let's say I ask you to work out the wavelength in this example. Remember, guys, let's say I gave you this. Let's start on a new page here. I gave you velocity 3.75. All right, I gave you the frequency, which was 5. And I ask you to work out the wavelength. Use your equation. Go and fill in. 5 times my wavelength. And then to get my wavelength alone, you have to divide both sides with 5, remember? 5, 5. I'm going to cancel them out. And then you get your answer that will give you your wavelength as 0.75. meters. It will be your wavelength. Okay,